recording. That's what I wanted to do. All right, so it is now recording. So it's recording. Okay, you guys can hear me. All right. So as I said, I'm opening up the Jupyter Notebook here. And I'm going to rename this file. So this is going to be our basic pipeline, right? So it's going to be our pipeline code. So we are going to, let me think about this. Let's just call this main. Yeah, main ML, let's say, right? So main ML. This will be the file that you guys will use every time you're creating, so every time you're doing an algorithm, right, you're going to take this approach, okay? So really, all of your scripts should be really, my suggestion would be, let me switch over to the whiteboard. My suggestion would be that you create 2 files, okay? This is probably the best approach. So whenever you do your machine learning, you're going to have 2 files, right? Let's say you're going to have main underscore ml.py or however you want to do it. And then you're going to have the actual algorithm. So for instance, you're going to have knn.py. Do you see that? So in knn.py, we're going to have basically the functions that we need. We could do this in object-oriented programming if we wanted to, and we might look at some examples later of how to do that as well, which should be pretty straightforward. Start reading up on, check out my video on the intro to Python. You can look at some of the object-oriented examples I have there, or anywhere on YouTube if you don't remember. But eventually, it would be, advised that you actually do this as a class, right? So as a class, let's say KNN, and a class naive Bayes, and a class so on and so on. So we're just starting now, but this is a good approach. So we're going to. So the idea is that here we define the ML algorithm. All right, so we're going to, our approach will be to define the ML algorithm here, and then this will be basically like the main, right? The main program. So whenever we want to do, so that way, if we want to run several machine learning algorithms, right, then we would have another file called, let's say, naive Bayes. .py, and so we could import both of those, right? So we can import both of those into our main file. That way, we could run the same data now on 2 algorithms, naive Bayes, KNN, and so on. So that will sort of be the approach that we take in this course. So that way, you can create your own list of algorithms that you will be using for all your machine learning needs. So as you might imagine, here is what we're going to process the data, and everything else, feature ranking, scaling, everything. And that way we keep things separately. In particular, today though, I want to focus on performance. I want to start with performance metrics, okay? So we're going to start with accuracy, and I'll start with the intuition of that. So this would complete, the pipeline, right? So we'll talk about accuracy, and so how to write that code, and you'll see it's actually quite straightforward. And then after that, on the lecture on Wednesday, I will go over, okay, but it's not just accuracy, there's precision, recall, F measure, and so on, right? The confusion matrix. So all of these performance metrics are actually derived from the same data. So all you have to do is get the data, and then you can kind of start processing, all right? So today we'll just start with accuracy, the simplest one. But as we go along in the semester, we will be deriving the code for all of these as well. And I'll start giving you the intuition of these metrics on Wednesday. Does this make sense, guys? So start getting into the habit of writing your code like this, okay, as much as possible. Today, therefore, that's why today I will be creating 2 files, as I said, main ML, and then later we're going to go over naive Bayes. Okay, we're going to go over this one a little bit later. Yeah, a little bit later today. All right, any questions about that? All right, doesn't sound like there's any questions. So let's go ahead then and get started. All right, so I'm going to switch over to, and it's actually not a lot of code, so we'll see. I'm going to switch over back to the Jupyter notebook that you have. So here, you know, I'll start, we already know that the name of this file is main.ml. So usually how this is going to work is, you know, you can say my main function. And can you guys see this? Is that big enough? Yeah, I don't know how to make it bigger. All right, so my main function, ML function. Okay, so as we start doing this, the first thing we will import is numpy, right, as NP. As you can see, numpy is the heart of this. Later on, we will start playing around with, you know, other powerful libraries like sklearn. We're not really going to use sklearn for machine learning in this course so much, but we will use some of its functionality for, like, you know, the fact that it has data sets already in it. Okay, and so I'm going to say sklearn import data sets. Now, it might be that this requires the installation of sklearn, but it didn't apparently. So apparently we do have sklearn. So that's what's so great about Anaconda, right? So I expected this actually to fail, and it didn't. So that's good. All right, so that means we have sklearn already in there. And we have the data sets, okay? Now, there's a lot more that we can do with sklearn, but in this course, you know, this is a foundations class, so I don't really want to just get you using tools. I want you to understand the algorithms themselves so that, you know, you have a better understanding of the foundations. All right, so there's, you know, there's also a Matplotlib. You know, if we wanted to plot, you know, I won't be spending so much time on plotting. I'll use it a couple of times. The 265 class, Intro to AI, will cover plotting. Also, you have a 400 level visualization class taught by Professor Gurjin, and that one is all about visualization. So I'll let them deal with that. All right, so now the question is, once you've done this, let's say that you created already, remember I said, you know, you have another file that you created, the KNN file, right? And so what you would do is you'd say from, this is how you import your own modules. You can say from, you know, let's say my KNN, right? My KNN, something like that. Import my KNN, right? Right, so this is just, I want you to understand that this is really just your own file. This is your own file, okay? So the class that we did last week, you know, basically, or your homework, really, your homework assignment, which is getting, you know, the code that I gave you and just kind of finishing it up. So that's the class. So really, assuming you have the class, then all that remains is to, let's say you would run your data, right? So you would run let's say here we have an example. You have an example here where you take some data. Let's say you got data from the iris data set from Fisher's iris, right? And you can get this from that data sets module that we just imported. So you can say data sets dot load iris. You see that? So that gives you a data set to use from the built-in data sets. Then you can, again, you know, our X and Y, right? So our X and Y, remember how much time we spent on that. Our X and Y really just don't change. And so you're going to be using that X and Y for your analysis. So now we can do, oops, sorry. We can do iris dot data, which will be the X data, comma, and iris dot target, right, which will be the labels. So you get the data set from there. And okay. Oh yeah, my own module will not run because I have not imported it yet. So let me clear that. Yeah, so let me just comment this out for now. All right. There you go. So you have your data. So really quickly, really easily, you're able to pick up a data set. What is iris? Fisher's iris is something that you will be using a lot this semester. It's just a little tiny data set that allows you to, you know, test your algorithm. So Fisher's iris is the classic data set. And it's basically pretty simple. It's got 150 samples. It's got 4 features. And it's got 3 classes. And basically it's about, I think either trees or flowers, and it measures, I think it's trees, and it measures certain things about the flowers, like, or the tree, the stem size, the stem width, this part of the plant height or length or something like that. So it's all measurements. And then based on that, it tries to predict the type of plant or flower that it is. All right, so that's basically the idea. So this, as I said, this is something that you can always use. Remember, we're trying to use a tool for kind of gauging how well our algorithm works. All right, now once that you have X and Y, divide your data into a train and a test set. So then we're going to say X train, comma, X test, comma, Y train, comma, Y test. All right, so these are the 4 basic matrices and vectors that you're going to get. So we're basically splitting our X and our Y into the training set and the test set. Okay, now what's important is here we're going to use from, again, just to keep things pretty simple for us, from sklearn, so we don't have to do this manually, because in these kinds of things, it's just best to use the library. From sklearn dot model selection, import, and then we're going to import something called train test split. Okay, so train test split. So that's a modular function. So then we can call it down here, train test split. And now we're going to split our data. So we take our X, comma, Y, right? The original ones, these 2. And we're going to run them through this function, and the function will return this. But we have to provide some parameters. So we need to say that we want the test size to be, let's say, of size 0.3. 0.3. or that means that it is basically 30% of the data will be for the testing and 70% of the data will be for training. So I think it's about 120 samples for train, and then the remaining 30 samples for test. All right, and then usually over here you can specify what is called a random state, and this just allows you to set a number that allows you to initial, like a seed number, to initialize your randomization algorithm, given that you're going to basically take the 150 samples and kind of like jumble them around. Imagine like you take 150 tennis balls and you move them around all over the place, and then you draw one, right? So it's randomly selecting. So we can just pick a number, 42. All right, and that basically then gives us, our X and Y train test, as you can see. Okay, and that's pretty much it. After that, we should do scaling. So we should do scaling here of our data, scale the data. We should do that. As I said, remember, I'm giving you this so that going forward, even though sometimes you have to create your own data, because we want to measure, when you measure something, right? Let's say that you measure precision. Let's say you take an engine or something, right? You're taking all the engines, right? You're taking all the engines with the same parameters in the same lap and so on, so you can have measurements. And so it's a good thing to use like Iris, a well-known data set, to kind of tweak and make sure that your algorithm is working well, because Iris, with all these algorithms, should do really well. Okay, it always does like above 90% or something. So if you're not getting those values, that's a good indication that there's something wrong in your code. Okay. Additionally, I've already posted Iris data on the website of the course, and you can also use Weka on it. Again, the only goal of that is to make sure that your algorithms are correct. Okay. You will use it as I keep thinking of a word that I want to say, but I can't think of it right now. But it's how you will gauge that you've written your code correctly. Okay. So here you would scale the data. I'm not really going to get into that. You don't really need to scale the data to get good results with Iris right now. So I'm just leaving that kind of there in the pipeline for now. You could get, the shapes. You could do plotting of all kinds, things like that, right? But after this, you've imported your, let's say, to kind of look at the pipeline, you've imported your own MyKNN. I just, I commented this out right now because I don't really have the file yet. You guys, this is what you're working on your homework assignment, right? So you will need to have this working. But let's say that now you have your KNN there, so you can use it. So then you're going to specify, well, I want 5K, right? So 5 nearest neighbors. And I'm going to create then an object, call it my ML, right? Or something, algorithm or object, whatever you want to call it, right? And then now you will call your own program, your own class. So from MyKNN, import MyKNN. So you're going to say MyKNN, right? And you specify that you want, based on how you wrote your class, K equal K, or you can say K equal 5 directly in there. Do you guys see that? But in an object-oriented approach, you will create now your own object, myML. Now, in that class that we will talk about currently, you really just have the functions, right? You have kind of the functions directly. So you will do something like myML, and I don't remember the functions that we created, but in essence, you always want to have fit or train, let's say train, right? And then myML dot predict. Oops. Predict. Right, and we went over these two functions, or KNN actually, we only have predict, right? We didn't have train, but in other ones like naive Bayes now, it will have the idea of train, okay? So it will have this my ML train, and then it has my ML predict. Are there any questions so far, guys?
Yeah, I do have a question. I'm sorry I missed like the first little bit. I had a call, but the homework is due in a couple of days. This is the accuracy portion of it, correct?
Yes, this is the accuracy.
Um, so do you want us to add this before we turn it in, or are we doing this afterwards?
You don't have to do this for the homework. This is, you know, did you see what I wrote on the whiteboard? What I explained on the whiteboard?
No, I missed that part. I just came in as soon as you started typing on Jupyter.
You just came in? Okay. Let me go back to the, like, maybe that'll clear. It's pretty simple. What I said is so you guys are currently working on that file, right? The one that you see there, this one.
Yeah.
That's your homework, right? But what I'm saying is a good mechanism will be to always have, you know, a file called main ML, which is the one I'm currently working on. You see that?
Mm-hmm.
And then what you're going to do is every time that you're going to run an algorithm, you import the particular one. So for instance, the homework, KNN, or you would import the next code that we're going to look at, which is naive Bayes. But you're always importing them, because that way you could say, you can compare KNN against naive Bayes, right? You grab a data set, data here, which is what I'm doing, and then you run KNN, and then you run naive Bayes, and all the other algorithms, and compare the performance between the metrics. So it's a good idea to have these two as separate files. You see that?
Yep. Okay. No, I understand. Like I said, I just missed the first part of the class. So, okay, that makes sense. Thank you.
That's what we're doing, yeah. So that, you know, that's what I'm saying. Currently, this is homework 1, right? Homework 1. Just do that. And then make sure it works. Do it however. And then after going forward, though, we want to transition into this idea of we will always have this file. I already showed you how to use Iris kind of as a gauge. And then we'll start introducing the other algorithms. Okay?
Okay.
Any other questions? All right, so it sounds like it's making sense now. So today, and that's what I'm saying, we're focusing on this file, and I'm going to end the file with accuracy, okay? So that we can measure accuracy as part of our performance, because we have to measure the performance of machine learning algorithms. All right, so as I was saying then, this myML object is, you know, my KNN. So if you're going to have more than one, then you would say probably here myML KNN, right? myML KNN, because then you could have myML naive Bayes and so on. So you kind of want to have sort of that. Usually you will have two functions, which are train and predict. KNN didn't really have train because it's a lazy algorithm. But naive Bayes, as we will start looking at it today, you'll see that it does indeed have basically a predict and a train. All right, so now that I've defined these, so basically in the train, what would we train with? We're going to train with X train and Y train, right? So we already got these data sets kind of split over there. So we're going to say KNN, oh, sorry. We're going to say train, or X train, sorry. X train. And we're going to say Y train, right? Those are, that's the data that we're going to provide usually. And then over here, we're going to say X test. X test, right? So if you notice, we used this one, we used Y train here, and then we're using X test. And it seems that we're not using Y test. So Y test is the actual real data that you annotated beforehand. So a human looked at all this data and said, yeah, that plant is, you know, Setosa, Virginica, or versicolor, one of the three classes. All right, so it's been already labeled. Now remember that in the predict function, you don't have to give it y test. Instead, the algorithm should predict the labels, right? So the labels of X test, the real ones, are in here, the real ones. But we want, obviously, a model that can predict, because in the future, let's say a year from now, we're going to have new data, new X test data. And so when we run that X test data through here, we won't have labels for it, right? Because we're trying to predict the stock market, whatever it is. So therefore, we need a model that can only work with X test data. However, as we are trying to create our algorithm and make sure it works correctly, we need to have some label data, some labeled classes, or some classes associated with X test, because what we're going to do is we're going to run my KNN predict with X test data, and it should return what I usually call Y pred. Okay, and what Y pred is going to be the labels for the predicted labels for X test. Therefore, let's say we know that there's 30 labels here because X test has 30 samples. So we're going to get here a vector of 30, and Y pred will also have size 30. So it'll also be a vector of 30. And that way, we will take the two vectors and compare them to each other. So now we will have, if I go back to the whiteboard, right, so if we go back to this whiteboard, this is a very important concept that I'm introducing today, that we're going to have now from X test, right? X test, which we run through the model, whatever it is, KNN, etc. This will output Y pred. Y pred is a vector, for iris, right? So this is iris. So it's a vector of 30 by 1 of labels. And then Y test is the original data annotated by a human, also of 30 by 1. So now the question is, does our algorithm perform as well as it should? So we've got some classes here. Let's say 1, 1, 0, 0, 1, dot, dot, dot. So how do you evaluate the accuracy of your algorithm then, based on what you have here? What would you say? How do you measure accuracy?
Compare the pred versus the test data.
Compare the pred versus the test data, right? So if I get a 1, 1, 1, 0, 0, 1, dot, 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 what would you say about the accuracy of this one?
100%.
100%, right? Now, what if I get, this one is a 0? How many errors do I have at least here?
1 out of 30.
1, right? Because these two do not match. So if you look, these do not match, but these match, that matches, that matches, that matches, that matches. That is how you measure accuracy. Okay, guys? It's like you have to guess the numbers, and you guess the numbers, and then you look under the hat and look at the real numbers, and you want to see, okay, did I guess the right sequence of numbers, right? And then you measure how many times you made a mistake out of that 30 samples. And that is the simplest performance metric, called accuracy, okay? Which is the only one that we will look at today, given that the other ones are a little bit more complex. And so we're going to take a look at the simplest one, just so that we get the code for that. And then after that, as I said, I'll start laying out the intuition for the other metrics as we start building them in the course. Any questions about this idea? This is pretty important. This is performance metrics. It will be on the exam for sure. So are there any questions? All right, doesn't sound like there's any questions, so I'm assuming that was clear enough. So let's go ahead back to the code then. I'm going to go back to my Jupyter notebook here. You can see. And now that you understand the notion of Y test over here and Y pred over here, what we're going to do is, now, obviously sklearn and all of those have their own functions for that. And later on, if you take 520 and if you take 530 deep learning and all that, you'll learn a lot of those built-in functions. But in our, this class, foundations, we really want to understand as much as possible of how everything works, right? And you will see actually that these are really very straightforward things. So really, all it takes is, first of all, we want to do a print here. At this point, we would say something like, we would say, KNN accuracy results, right? So you would write some kind of something like that, right? And then after that, you want to print out the actual result. So usually what makes sense here is to create a function, all right? So what I'm going to do is I like to separate code like this. You don't have to do this. This is just me. So I breaking it into the blocks of the pipeline basically, so they're easy to find. And so now after I do the KNN and everything, imagine I also would do naive Bayes in here, my own object oriented. So now I need an accuracy function. Okay, so I'm going to need an accuracy function. So what that accuracy function takes is it takes let's say let's call it accuracy result, right? And it will be the result of calling a function called accuracy. All right, so I have a function called accuracy, and it needs to take 2 parameters. So obviously the 2 parameters I discussed on the whiteboard. So that's going to be y test, right? Y test, which is, this one over here, the real data, right? And comma separated by y pred, okay? Y pred is the predicted code over here, okay? Okay, guys? So then I have both of my, I have my 2 vectors, and now I would need to run them through the accuracy function, get a result, accuracy result, and then just print that. Accuracy result. All right. So again, I've given you most of the code, but I will leave it to you guys to kind of finish it up. Obviously, because you need this part, right? You need this part of your KNN. Now let's go ahead and define the function accuracy. So we still need to do that. So this is going to be define accuracy. All right. And we know that it takes y test and y pred. It takes y test, comma, y pred. You can see that there. Kind of very nice and clean. And so now what you have to do is all that's left really for this metric is to define our code. And once again, we are going to look at, we're going to use numpy. Right? So first of all, this is going to return an accuracy. So I'm going to call this accuracy value. I just like naming things. Oops, sorry. I'm going to do accuracy value or result, whatever you want it to be. Doesn't matter really. And now here comes the magic. So accuracy value, we have to think about it, right? So how do we calculate accuracy value? That's the question. So for this one, what do we need? We need to take the 2 vectors, right? And what Josh said, pretty much, right? What Josh said, we need to take the 2 vectors. And so you guys should be seeing the whiteboard. So we have, the 2 y pred and y test, and then we've got, and then this one, right? So these are correct. This one's correct. let's make this one correct too. But these two are wrong, right? So that's wrong, that's wrong. So that's what we need to do. So we need something, maybe a way, to say which ones of these are equal, which ones of these are false, right? So we would need a new vector that compares both of these and says, okay, true, false, false, true, true. You see that? This captures the information that we need. And in fact, the convenience about this is that this vector will be written like this, right? So if it's written like this, right? And if we have 1, 2, 3, 4, 5, we have 5 values there total, and 3 of them we sum them. That's 3 out of 5. So that's what, 60% accuracy, and that's actually exactly what we need. So we just need a way, Python, find a way in Python to compare equality. Well, actually, I should say compare equality over here, obtain something that looks like that, and then once you obtain something that looks like that, you just sum it, and boom, job done, right? So pretty simple. So then what we need to do is, if we go back to the code now, you can see it's pretty straightforward, really. We just have to, first of all, take the two vectors. So we can take y true equal y pred, and by just doing this, for the two vectors, the result of that is that new vector that I told you about. And so that takes care of it. So then all we have to do now is we take, we need to get, we need to sum these values in this resulting vector. How many of those are ones, right? So to do that is pretty easy. We just say numpy dot sum, and that's it. So what does that give us if we go? So this gives us, if we look back at the whiteboard, this gives us 1, 2, 3, right? So we just got the number 3. What else do we need?
The total.
The total, right? So we need to divide by the total, and so to do that, we just division in Python, right? And we divide by the total, so that's the length of either one of the two vectors, right? Either one of the two vectors, either y test or y pred, it doesn't really matter. So let's say y test, first one, and that's it. Do you see how simple that is? And this will work really well. The fact that we're using numpy makes it, pretty efficient. So this is actually good code, all right? May not be at the big data level or TensorFlow level, but it's still way better than for loops. So that's, this is the kind of code that you should be writing. Remember, I've been showing you about numpy, and we will continue that, obviously, for the rest of the semester. And that's it. This is your main code. Hopefully this now gives you a pipeline, right? So before we were just focusing on the algorithm itself. Now we are focusing on a pipeline. And we have a good pipeline here that you can model. So now you will have a way to measure your KNN algorithm, right? So I know the homework is due on Wednesday, and I don't really want to delay it. So just submit what you have as far as your algorithm. But keep in mind, you could easily just test your algorithm with this and see how it's performing. All right. Are there any questions, guys?
Will you be uploading this to a Brightspace?
Yes, I can do that. I can do that.
Thank you.
So there's actually in Jupyter Notebook, there's a way. also save the Python, I know that I've used this. Do this the other day.
There was a save as option. You might be able to save it as a Python file.
I know I did it the other day. So it is something. Maybe it's the save as. Nope. Download as. There we go. Download as, and this will download it also as a .py. You see that? And so that way I'll load it as both of them. Yeah. All right, so I'm hoping. All right, so now let me, before I forget actually giving you this code, I'd rather just give you this code now. So, and I will load it on my GitHub later as well. So that this one is called, remember, main ML. Okay. And I'm going to also, you said the Jupyter, so. Okay, so I'm saving this, and now let's switch back to Brightspace. So you should be seeing Brightspace, and I'm going to go to performance metrics because this is this is about performance metrics and the pipeline. So I'm going to load up this file here. So this one should be main ML. All right, so that should be there. Also the script. The PY. All right, so both of those files have now been loaded on Brightspace. Please check that they're there, and you can use them. Any questions, guys? Did you get it? Did you see the file?
I'm loading it still.
All right, so if anyone has seen it, just let me know when you see it. All right, so now that we've done that, we've completed this. And this file, as I said, you will be using. So every time you do a homework now, you will have your main ML, and then you have your whatever naive Bayes or NN or neural perceptron, neural net, whatever we're going to be working on. And so now you have a little bit more power to do things. Okay. The next thing we're going to do today is now, given that, like I said, I was only going to introduce accuracy, I will cover in the slides. Okay, great. So I was going to cover in the slides on Wednesday. I'll cover the other metrics, kind of give you an intuition, and basically, now that you know how accuracy can be calculated, I'm sure you can start to figure out, as I start giving you the theory of recall, F measure, etc., you can start to write your own code, right? So you can start your own functions. So you would write your own, instead of accuracy, you would call it precision, right? And you just have to play with a few tricks of it, right? So you'll get a feel for it. All right, so that concludes our discussion of performance metrics and ML. So I'm thinking here, I'm going to create 2 videos, right? Because I really want to have this would be naive Bayes, a kind of a different one. So if you guys don't mind, what I want to do is I'm going to close this session and just come back again. That way I can generate the video for this, and it's its own independent unit, and then, or module, and then that way I don't have naive, that way you guys can find, whenever you just want this part, You don't have to go through the whole naive Bayes video and vice versa. Make sense?
Yep.
All right. So I'm going to close and I'm going to come back again. All right. All right. So here we go.